Hello everyone, welcome to the Electron Flow Academy. So our today's topic is response of circuit elements to the AC voltage source. So here we are going to talk about the circuit elements. So basically there are three circuit elements existing in the electrical circuits. The first circuit element is resistive load. Second circuit element is inductive, and last one is the capacitive circuit element. So firstly we are going to discuss about the resistor circuit. Okay, so we are going to discuss here what will be the response of the resistor element in the case of the AC voltage source. Okay, so firstly let us consider a voltage source. Okay, so we are considering a voltage source whose value is Vm sin omega t. है ना? Okay, next, here we are applied to this voltage source is applied to a pure resistor, which is the denoted here as a capital R. Okay, so basically if I draw the waveform for the voltage and current, so here, so this waveform is of voltage. Okay, and this smaller waveform is of current, because we know that as per the Ohm's law, I is equals to V divided by R. Okay, so basically the value of the R is at the denominator. Okay, so in the on the numerator there is a voltage. So whatever the value we achieved of the current is always less than the voltage. Okay, so this is the waveform for the resistive circuit. Another thing is here that the phase angle difference between voltage and current is equal to 0. Okay, so this we are going to prove is here. Okay, so next, okay, so this is our voltage source. If I talk about the RMS value of the voltage, so the Vrms is equals to Vm divided by root 2. Okay, at an angle of 0 degree. So again I am repeating here according to Ohm's law, current flowing through the resistor is given by this expression. Okay, so what I am doing here, I am putting the value I will be maximum value divided by resistance sine omega t. Okay, so what we are doing basically, this is the voltage waveform equation divided by R resistance. Okay, so here I am assuming I will get this ratio is equal to Im. Okay, so Im sine omega t. So we have two equations here. This is our first equation and this is our second equation. Okay, so next, Im here is the maximum value of the current. Okay, so the phasor of the current, if I write this value in the terms of phasor, so I will be again Im by root at an angle of 0 degree, because here the value of angle is 0 degree. Okay, so from the equation 1 and 2 it is clear that in the pure resistance voltage and current are in the same phase or same phase, or in other word we can say that the phase angle difference between the voltage and current is equal to 0. Okay, so what will be the value of the resistance here? So we will get R is equals to voltage at an angle of 0 degree divided by current at an angle of 0 degree. Okay, So this will be the value of the resistance. Next, we have to give the relation for the power. So if I talk about the power relation, what will be the power relation here? Let's see. Firstly, the instantaneous power consumed by the resistor, we know that is given by P is equal to V times I. Okay. So here I can write the both equation. Vm sine omega t multiplied by Im sine omega t. Okay. So let's multiply both the value. Then I will get Vm Im sine square omega t. Also I can rewrite this like Vm Im divided by 2 into 1 minus cos 2 omega t. We know that the sine square theta is equal to 1 minus cos 2 theta divided by 2. Okay, so next thing is that the average power consumed in a one cycle given by, let's take it in the next page. We are here calculating the average power in one cycle. So you can write this like P equal to 1 upon periodicity, which is for one cycle is 2 pi. Okay. And we are calculating the area from 0 to 2 pi. Pm Im sine square omega t. Okay. D omega t. This expression we are getting here from this value. Okay. From here we are getting the equation of the power. Okay. So next, if I am going to solve this equation, so here I am putting put omega t equal to theta. Okay, so next let's solve this equation. Now power is given by Pm Im upon pi integration 0 to 2 pi. As we know that the sine square theta is equal to 1 minus cos 2 theta divided by 2 d theta. Okay, so let's solve this equation is equal to Vm Im upon 4 pi okay, and we are applying the integration concept here 0 to 2 pi. Okay, so this value will be equal to 2 Vm Im divided by 4 pi into 2 pi. Okay, so further if I solve this equation, I will get the value of the power is equal to Vm Im divided by, or I can write this equation like Vm by root 2 multiplied by Im by root 2. Okay, so indirectly I can say that the power is equal to, in the case of the resistive circuit, is multiplication of RMS voltage with the RMS current. Okay, so which unit is in watts. Okay, so here the V is the RMS value and I is the RMS value of the current. So it is important note that the instantaneous power is never negative. You can see here this waveform is of voltage and this waveform is of current. So if I multiply the both values, those both values are in positive region, I will get the positive value. So that's why this waveform starts from here. Okay, and at this point, power will get the zero because the current and voltage are both is equal to zero at the instant of the pi. From pi to 2 pi, both voltage and current are in negative. Okay, so the multiplication will also positive. So again from pi to 2 pi, I will get the positive value of the power. So the average value of the power I will get here, which is equal to P equal to VI. This is the phasor representation, okay, of the waveforms. So this is how we can calculate the power in the AC circuit while the load type is resistive. Okay. So thank you very much. Kindly like and subscribe our channel.